Hello, this week we have learned about what is semiconductor and the semiconductor basic. Semiconductor is literally semi-conductor. Then what is conductor? Conductor is a medium for electron, but then then semiconductor can be uh, semiconductor is also medium for electron, but they can be switched to whether electrons can move or electrons cannot move. So semiconductor can be used to switch and amplify. To understand what's going on in semiconductor, then then we have to know about where electrons go. Electrons move because when we fully understand of moves of electron, then we fully understand of semiconductor. So if if we want to mathematically know where electron moves, then we have to know about mechanics basic, because uh, by Newton's law we cannot explain where electron is going because it's too small, and so we have to use quantum mechanics basic. To understand to understand mechanics basic, we have to know about energy quantization and quantum tunneling, and these two can explain about electrons two things. Electron can be a particle or electron can be a wave, and these two things can explain after we learn. For example, um, when we use Bohr's model, uh, the particle so the we can use energy quantization for explaining Bohr's model, because particle have a eigenvalue, so that the eigenvalue can have so that means light the electrons no the particles uh, light energy can have a discontinuous eigenvalue. So we have to see where so what we really have to see is the discontinuous light energy orbit, and the second thing is it can be moved by orbit when they get a energy or they lose energy. So let's say example for that about, let's say, hydrogen, for example. Hydrogen has one proton, one neutral, and one electron. And when we draw our energy of hydrogen's particle, uh, hydrogen molecules, sorry, um, this like this, it has a discontinuous energy level. But but if we have a lot of hydrogen molecules, then this energy orbit are can be seen by continuous band, one each band, like this. So when the electron's energy when then so this is the this next step, this can be explained by conduction band and forbidden band and valence band. Valence band is the where electrons really stays when they are in 0 Kelvin and no energy. But if they get energy from another, electron can move to conduction band like this, and they cannot be in forbidden band. So if the electron get energy and go up to the conduction band, they get a free electron, and free electron means that they can be they can be they can be flow of electrons. So when we say when the electron get energy, we call excited electron, because and there will be a hole left when the electron goes up, the then the hole is just to stay there, and the hole means that they get that got a plus for one. And if they have to if they want to get if the electron get an energy but less than the forbidden gap, then they cannot go up to conduction band. But if the electrons get a more than forbidden gap's energy, then they can go up to the conduction band. This is the insulator and semiconductor and metals are sized by are the their forbidden gap size can decide what that is. Like insulator has a largest forbidden gap, like 9 electron volts, and semiconductor have 1.12 electron volts, and metal have none. So metal can be moved freely because they don't have to get energy to go conduction band, but semiconductor have to get a 1.12 electron volts to conduction band, valence band to conduction band, and insulator 9 electron volts. So, we dope of we doping we dope semiconductor to uh to to get a really the natural semiconductor is useless because they cannot flow electron, because uh only natural Si molecule is like that and like that and like that. There is no space for this electrons. Electrons goes because they get stuck like this, like this. But we if we dope group 3 or group 5, there will be a hole like that. Group 5 or group 3, there will be a hole or or free electrons that can be moved. Sorry. So if we dope group 3, then we call it p-type semiconductor, and if we dope group 5, then we call n-type semiconductor. Also, n-type semiconductor can be called donor or p-type semiconductor can be called acceptor. P-type semiconductor is when the hole is dominant to p-type semiconductor and electron is dominant at n-type semiconductor. But how can we how can we see difference between p-type and n-type to at energy band level? Then we have to know about what is the Fermi level is. The Fermi level is a possibility about whether half of electron can be. So like if Fermi level is about this up, under the Fermi level there will be a 50% of electron possibility. But then when we see an n-type semiconductor, under the Fermi level there will be a 50% of electron possibility. Well, we can mathematically calculate Fermi level by Fermi Dirac distribution. And lastly, we learned about PN diode because p-type and n, when we get a p and n-type, p plus n-type, there will be a move of electron. If we see about this energy level, there will be a depletion region because there and this is n-type, p-type, the donor acceptor, and this is plus minus. So there will be this depletion region, and we can draw Fermi level of 50%, and what we saw this is just what I draw up here. To understand the electric field of this and potential of the electric, we have to use the Poisson equation for this. For Poisson equation, we can know about. Firstly, we can draw a charge for P and N junction, P and N type junction. P-type junction have a charge of this amount, and N-type, N-type. M-type junction can have this amount of charge, and yeah. P-type, P-type junction has this much of charge. And this area can be decided by how many doping you are going to do. And if we see about a field of P and N junction, it can be like this. So finally, so overall, we have learned about semiconductor basic for to understand semiconductor. But before we understand semiconductor, we have to learn about where electron moves in semiconductor and how different with insulator and metal, and we have learned about quantum mechanics basic, and to explain that we have used Bohr's model, and to explain example of Bohr's model can we use the hydrogen molecules, and when after that hydrogen molecules have this continuous energy level, so we can explain about conduction and the valence band and band gap, where electron place, and to move electrons well in semiconductor, we have learned about doping. So in doping semiconductor, there is two different of semiconductor, which is p-type and n-type. And we have used the Fermi level to explain what is p-type and n-type semiconductor, and we have learned about p and n-type uh, plus. And I have one question that if doping, if we do a different amount of doping in at p type and n type, then this area this area this area can be different, right? Then how come field get 0 to something to 0? I think this have to be like this, I think. And that is my question. So this week, this is my review for semiconductor.